Hello friends, in this session I explain frequent pattern growth algorithm, or we can say happy growth algorithm. Our priori algorithm was explained in details in our previous tutorial. In this session I will learn you about frequent pattern growth. A happy growth is a method of mining frequent items. As we all know, Apriori is an algorithm for frequent pattern mining that focuses on generating item sets and discovering the most frequent items. It generally reduces the size of the item set in the database. However, Apriori has its own shortcomings, like using a priori needs a generation of candidate item sets. These item sets may be large in number if the item set in the database is huge. Second is a priori needs multiple scans of the database to check the support of the each item sets generated, and this leads to high costs. So these shortcomings can be overcome using happy growth algorithm. Now I explain frequent pattern growth algorithm. This algorithm is an improvement to the a priori method. A frequent pattern is generated without the needs for candidate generation. Happy growth algorithm represents the database in the form of a tree called a frequent pattern tree or happy tree. This tree structure will maintain the association between the item sets. The database is fragmented using one frequent item. This fragmented part is called pattern fragment. The item set of these fragmented patterns are analyzed. Thus, with this method, the search for frequent item set is reduced comparatively. Now I explain about happy tree. Frequent pattern tree is a tree-like structure that is made with the initial item set of the database. The purpose of the happy tree is to mine the most frequent patterns. Each node of the happy tree represents an item of the item set. The root node represents null, while the lower nodes represent the item sets. The association of the nodes with the lower nodes, that is, the item sets with the other item sets, are maintained while forming the tree. Now I explain frequent patterns algorithm steps, or we can say happy algorithm steps. The frequent pattern growth methods let us find the frequent pattern without candidate generation. So it's also called a algorithm of happy tree without candidate generation. Let us see the steps followed to mine the frequent pattern using frequent pattern growth algorithm. So first step is find out the minimum support for the database or even example. In general, minimum support is given in digit, but if minimum support is given in percentage, then we have convert that support into digit with below equation. So equation is minimum support is equal to given support, which is available in percentage into total transaction divided by 100. I explain this with example like if support threshold is 50% given and total transaction is 6. So put that support value and total transaction in our example. So we have find out minimum support is 3. Now next step is to scan the database to find the occurrence of the item set in the database. This step is the same as the second step of Apriori. The count of one item set in the database is called support count or frequency of one item set. Now, the next step is prioritize the item set, or we can say we can give priority of each item. Means we have give the priority of each item according to its frequency of occurrence. At the same time, you have opportunity to drop the items which not fulfill the minimum support requirements. This drop out the item is based on the user. It is not compulsory to drop items in these steps. You can drop in further. So next step is order the items table according to priority. Means we can order items column in that all the items are queued according to its priority, which mentioned in the earlier step. The next step is to construct a tree. For this, create the root node of the tree. The root is represented by null. The next step is to scan the database again and examine the transactions. Examine the first transaction and find out the item set in it. The item set with the maximum count is taken at the top. The next item set with lower count and so on. It means that the branch of the tree is constructed with transactions, item sets in descending order of count. Then the next transaction in the database is examined. The item sets are ordered in descending order of count. If any item set of this transaction is already present in another branch, like in the first transaction, then this transaction branch would be shared a common prefix to the root. This means the common item set is linked to the new node of another item set in these transactions. Also, the count of item set is incremented as it occurs in the transactions. Both the common node and new node count is incremented by 1 as they are created and linked according to transactions. These steps is understood in the numerical part. Now, next step is to mine the created FP tree. For this, the lowest node is examined first, along with the link of the lowest nodes. The lowest node represents the frequency pattern length. For this, traverse the path in the AP tree. This path or paths are called a conditional pattern base. Conditional patterns base is a sub-database containing of prefix path in the AP tree occurring with the lowest node, or it also known as suffix for that. The next step is construct a conditional AP tree, which is formed by a count of item sets in the path. The item sets meets the threshold support are considered in the conditional AP tree. The next step is frequent patterns are generated from the conditional AP tree. So these are the steps for creating frequent patterns algorithms. Now I explain numeric example of AP growth algorithm. Now see in table we have 6 transactions and that transactions includes different items like transaction T1 includes I1, I2, I3 items. Transaction T2 includes I2, I3, I4 items. Transaction T3 includes I4, I5 items. Transaction T4 includes I1, I2, I4 items. Transaction T5 includes I1, I2, I3, I5 items. Transaction T6 includes I1, I2, I3, I4 items. For this example, support threshold is equal to 50% and confidence is equal to 60% is given. Now I explain solution for that. So we have start with step number 1. In step number 1, we have find out the minimum support from the database or given example. In this example, support threshold is equal to 50% is given. And we have see the total transaction is 6. So put that value in equation like minimum support is equal to given minimum support which is available in percentage into total transactions. So minimum support is 50% and total transaction is 6. So put that value in our equation. So 50 into 6 divided by 100. So answer is 3. So we can say minimum support for this example is 3. Now I have explained step number 2. In step number 2, we have to scan the database to find the occurrence of the item sets in the database. Now, based on the given table, we have find out individual items with their count. So, in this table, we have I1, I2, I3, I4, I5 individual items. In this, we have only identify unique items. So, count of each items like I1 occurs 4 times. Like I1 occurs in T1 transaction, T4 transaction, T5 transaction, and T6 transactions. I2 occurs 5 times. Means I2 occurs in T1 transaction, T2 transactions, T4 transactions, T5 transaction, and T6 transactions. So this way we have find out count of individual items. So I3 occurs 4 times, I4 occurs 4 times, I5 occurs 2 times. Now in next step we have prioritize, or we can say priority the items. Means based on the original table we have find these individual items count, and the count like I1 occurs 4 times, I2 occurs 5 times, I3 occurs 4 times, I4 occurs 4 times, I5 occurs 2 times. Now we have sort the item set in descending order. So it looks like first items is I2 because it has a highest count like 5. Then we have include I1, their count is 4. Then we have include I3, their count is 4. Then I4, their count is 4. And last I5, their count is 2. Now in next step is order the items table according to priority. Means we can order input column all the items are queue according to its priority, which mentioned in the earlier step. Means in earlier step we have find out this table. In this table first we have include I2 items, then I1 items, then I3 items, then I4 and I5. This is their count. So final tables according to prioritized tables. Here we have see our original table. Now we have rechange in our original table based on the items which we have include in priority wise. So final tables like in transaction T1 we have include first item is I2 because their count is highest, then I1, then I3. In transaction T2, first item is I2, then I3, then I4. In transaction T3, first item is I4, then I5. In transaction T4, first item is I2, then I1, then I4. In transaction T5, first item is I2, then I1, then I3, then I5. In transaction T6, we have include first item like I2, then I1, then I3, then I4. So in our next step, we have consider this table. Now I explain combination of step 5 and 6 for built FP tree. Now see our original table. Based on that, we have create a FP tree. For that, first we have consider the root node. This is null. The first kind of transaction is T1 that include items like I2, I1 and I3, where I2 is linked as a child to root. I1 is linked to I2 and I3 is linked to I1. So count of this transaction is I2 occurs one times, I2 occurs one time, I1 occurs one time, and I3 occurs one time in transaction 1. So I have write I2 gem 1 means I2 occurs one times in these transactions. Now in second transaction like T2, T2 containing I2, I3, I4 items, where I2 is linked to root, I3 is linked to I2, and I4 is linked to I3. But this branch would share I2 nodes as common, as it is already used in T1 transactions. Now increment the count of I2 by 1, and I3 is linked as a child to I2. I4 is linked as a child to I3. We can see in this tree. So the count is I2 occurs two times in transaction T1 and T2. So it's known like I2 gem 2. Then I3 occurs one time. So their count is 1 for these transactions. And I4 occurs one time. Now in T3 transactions mean combination of T1, T2 and T3 transaction FP3. Similarly, a new branch with I5 is linked to I4 as a child is created. So count is I4 occurs one time and I5 occurs one time. Now in T4 transaction means this is the combination of T1, T2, T3 and T4 transaction FP3. In T4 transaction we have I2, I1 and I4 items. In that, I2 is already linked to the root node, hence it will be increment by 1. Similarly, I1 will be increment by 1 as it already linked to I2 in T1, and I4 is linked to I1. Thus, count is I2 is 3 times their count, I1 is 2 times their count, and I4 is 1 time for their count. Now, in T5 transaction, or we can say combination of T1, T2, T3, T4, and T5 transactions that include I2, I1, I3, I5 items, where I2 is linked as a child to root. I1 is linked to I2. I3 is linked to I1. And I5 is linked to I3. Now we have increment all the items counts. Thus the count is I2's count is 4, I1 count is 3, I3 count is 2, and I5 count is 1. Now, in T6 transactions means combination of happy tree is T1, T2, T3, T4, T5, and T6 transactions. That T6 transaction include I2, I1, I3, I4 items, where I2 is linked as a child to root. I1 is linked to I2. I3 is linked to I1 and I4 is linked to I3. Now we have increment all the count of that items. So I2 occurs 5 times, I1 occurs 4 times, I3 occurs 3 times, and I4 occurs 1 time. So this is the final tree of the happy tree, which include all the transaction like T1 to T6. Now I explain step 7 to 9 combination for construct a conditional FP tree and find frequent patterns are generated from the conditional FP tree. Now see the final FP tree which include all the transactions. Now see the lowest node items I5. I5 is occurs in two branches. First is I2, I1, I3 and I5. Second is I4 and I5. Here the count is I5 is 1. So we can write like I2, I1, I3. Their count is 1 means gem 1 and second branch is I4 gem 1 means I5 occurs one time in these two branches. Now I2, I1 and I3 is not considered as it does not meet to the minimum support count. So it is deleted in the conditional FP tree and frequent pattern generation. So now in next lower node is I4. I4 occurs in three branches like I2, I1, I3, I4. Second is I2, I3, I4. Third is I2, I1, I4. In three branches, I4 occurs one time. So we can write like I2, I1, I3, gem 1 means in this branch I4's count is 1. And second is I2, I3, gem 1 means in this branch I4 count is 1. And third one is I2, I1, gem 1 means here I4 count is 1. Therefore, considering I4 as suffix, the prefix path will be I2, I1, I3, gem 1, I2, I3, gem 1 and I2, I1, gem 1. This form the conditional pattern base. The conditional pattern base is considered a transaction database. Now, conditional FP tree is constructed. This will contain I2 gem 3, I1 gem 2, I3 gem 2. This path will generate all combination of frequent patterns. So frequent pattern is I2, I4 gem 3. Next is I1, I4 gem 2. Next is I3, I4 gem 2. Now for I3 transactions, I3 occurs in two branches like I2, I1, I3. Second is I2, I3. In first branch, I3 count is 3. In second branch, I3 count is 1. So the prefix path would be I2, I1 gem 3. Next branch is I2 gem 1. This will generate a two node FP tree. So that is I2 gem 4 and I1 gem 3. And frequent patterns are generated like I2, I3 gem 4 and I1, I3 gem 3. For I1 occurs in one branch like I2, I1. Their count of I1 is 4. So the prefix path would be I2 gem 4. This will generate a single node FP tree. So I2 gem 4 and frequent patterns are generated I2, I1 gem 4. So I hope you can understand how to create this table. Now I explain advantage and disadvantage of FP growth algorithm. The first is advantage of FP growth algorithms that include this algorithm needs to scan the database only twice when compared to Apriori, which scan the transaction for each iteration. Next is the pairing of items is not done in this algorithm and this makes it faster. Next is the database is sorted in compact version in memory. Next is it is efficient and scalable for mining both long and short frequent patterns. Now, disadvantage of FP growth algorithm is first is FP tree is more cumbersome and difficult to build than a priori. Next is it may be expensive. Next is when the database is large, the algorithm may not fit in the shared memory. Now I explain difference between FP growth and a priori algorithms. This difference categorize or we can say the main characteristics of this difference is first is pattern generation, second is candidate generation, third is process, and fourth is memory usage. Based on these characteristics, we have identified or say difference between FP growth and a priori. So first is pattern generation. For that characteristics in FP tree, FP growth generates pattern by constructing a FP tree. In a priori generates pattern by pairing the items into singleton, pairs, and triplets. Now, the second characteristics is candidate generation. In FP tree, there is no candidate generation. In a priori use candidate generation. Now, third characteristic is process. So, in FP tree, the process is faster as compared to a priori. The runtime of process increments linearly with increase in number of items set, while in a priori, the process is comparatively slower than FP growth. The runtime increases exponentially with increase in number of items set. Now, last characteristics is memory usage. In FP growth, the compact version of database is saved, while in a priori, the candidate combination are saved in memory. So, conclusion of FP growth and a priori algorithm is the a priori algorithm is used for mining association rules. It works on the principle the non-empty subsets of frequent item set must also be frequent. It forms key item set candidate from k minus 1 item set and scan the database to find the frequent item. While in frequent pattern growth algorithm is the method of finding frequent patterns without candidate generation. it constructs a happy tree rather than using the generates and taste strategy of Apriori. The focus of the happy growth algorithm is on fragmenting the path of the items and mind frequent patterns. So I hope you can understand the frequent pattern growth algorithm. So thank you friends watching this video. I hope you can understand how frequent pattern growth algorithm works. Thank you.